Hello everybody and welcome back to Operation Logistics, where we pretty much just need to implement get nearest hex, and then we can start working on our actual putting together of the routes, which essentially would be just we enter route creation mode and place the origination point. And then once we have that, we can, I don't know, shift click to append a waypoint. And then we can click and drag on the waypoints to change where they are in the route edit mode. So that's pretty much where we're going with this, but for right now we need to go ahead and implement get nearest hex. So first things first, we do need to do this overlap sphere, and for that to really happen we need to know... Do we though? Do we need to know how big the world hex is? Well, yes and no. So let's go ahead and check in here. And we're just going to take a quick look here. This is scale of 111. And it would appear that overall this size, it's slightly smaller than 2x2 in the Z direction here, but we'll call it 2x2. Okay, so we're going to do a physics.overlap sphere. And here we go. And we're going to go ahead and pass in the position and the radius. The position is just position. Radius, we're going to go with 2. Now, of course, this doesn't do anything right now. We need to put together an array of colliders. So collider array, that's what it returns. And we will call this colliders equals physics.overlap sphere position 2f. Now, for each collider, we'll call it col in colliders. Then we need to do all of this within these brackets. So, if col.gameObject.tag equals the world hex tag, which is just like that. Okay. World hex. It's in consideration. Check to see if it's nearer. If so, set nearest hex. So, if, let's see here, if pose minus col.transform.position square magnitude is less than nearest distance. There we go. Then we set the nearest hex very simply with nearest hex equals col.getComponent world hex. Okay. So realistically, this should only be checking at a maximum 6. At a minimum, it should be checking something more akin to something like 2 to 3. So this should be reasonably fast. And now we have our nearest world hex. So we've gotten that. So that is excellent. Next, we need to find the nearest biome hex within the nearest world hex. And I believe in order to do that, we are going to... we have a helper function for that? I don't think so, but we can go ahead and assign our int3 here. So ret.world hex equals nearest hex dot hex index. Okay. Now we do need to check to see if nearest hex is not equal to null, but if it is equal to null, then we're just going to want to return ret. Although we may want to debug.log error. Yeah, we'll go ahead and do that. Debug.log error, and this will be hexmanager.getNearest hex No world hexes found within radius. Okay. There we go. And then if it does exist, then we'll go ahead and set the world hex. Next, we need to go through all of the biome hexes within the nearest world hex and find which one is nearest. So, for int I equals 0, I is less than world, or rather nearest hex. Nearest hex dot, this is going to be biome hexes. Those are a list of hex store. Actually, I think what we want is hex manager. We'll go to biome hex manager dot subhexes dot count, because we actually want to be using these because we want the transform dot position, and I don't really want to be using the helper function for this because it'll be slightly faster to do it this way, I think. Then I++. So we're iterating through all of our biome hexes to see which one is nearest. Well, we don't necessarily know that this is in the correct position, right? But we can still do this for the correct count. This'll be fine. So what we then want to do is we probably do want to use the helper function of get biome hex position, which I don't think we have. But we can go ahead and do this real quick. Public vector3 get biome hex position int3 hex. And then honestly, we can just take this here, paste it into here. No, I don't want a function breakpoint. I want to paste this in here. Return position. And there's our biome hex position. And then all we need to do here is vector3 pose equals get biome hex position int3, or rather just pass in hex. Okay, so that gets us our biome hex position. And I mean, technically we could do a world hex one too, but I don't think we need to just now. For one thing, world hexes pretty much just are what they are. So we need to iterate through our biome hexes here. So let's go ahead and say something along the lines of, let's see, we pass in an int3 here. So we want int3 position equals new int3, and we are going to pass in ret.worldHex I and 0. We actually don't care about the building hex. Oh, we already have a position here. int3 hex equals this. Okay, so we're going to iterate through all of this and see what is the nearest. So we get that, and then if position minus, and this is then going to be get biome hex position of hex. We do need this to be in parentheses. Dot square magnitude is less than, and we are going to need to go ahead and set nearest distance back to mathf.infinity is less than nearest dist. Then ret.biomehex equals I, and nearest distance equals, did we do this up here? No, we didn't. Okay. So nearest distance up here would need to equal this. There we go. And the same thing right down here. Excellent. Now, we don't actually have a col, because we're doing this differently. So we actually need to have it equal to this. Okay. So that gets us our closest biome hex. And then we just need to find our nearest building hex. And we're going to do that pretty much exactly the same way. For int I equals 0, I is less than, this is going to be building hex manager dot subhexes dot count I++. And once again, we're going to do this almost identically. We just need to do this for building hexes rather than biome hexes. So int3 hex equals, this is going to be a new int3 again. This is going to be ret.world hex and ret.biome hex. And we're going to pass in I as the building hex. And then very simply, if position minus get building hex position of hex, and this does need to be in parentheses, like so, dot square magnitude is less than nearest dist, which we need to set back to mathf.infinity. There we go. So if this is the case, then it's very simply ret.buildingHex equals I, nearest dist equals position minus, well, this here. Technically we could only do these calculations once, but I think they'll be fast enough to not worry about it. And then we just return our return value, and that should get us our nearest hex to the position for the world hex, the biome hex, and the building hex. Excellent. Seems pretty cool. Probably buggy, but there's a lot of things that we've implemented and not exactly tested recently. So there is that. So position 0 in the waypoints is the origination point. We need to decide if we can actually move origination points or not, right? And realistically, I don't think we need the origination point prefab. I think we just need waypoint prefabs. And then what about changing the position of waypoints in the list? That is something we might want to be able to do as well. So we're going to need to think about that. But let's go ahead and run this and make sure we haven't horribly broken anything. Make sure we go into root creation mode. I mean, we're not calling any of the new functions, so this shouldn't break anything. I mean, the generating seems fine enough. Okay, we'll go ahead and skip that tutorial. And we'll go into, oh, there's that garbage collection spike. We'll go into create root mode, and it does indeed do that. Now, one thing to note is I did, for my game that I'm working on off camera right now, I did actually create a function to add a space before capital letters in these. We might copy that in later on, but for right now this will be fine. So for create root mode, do you have to select a building hex? Or can you select a world hex? Well, I don't think it's very useful to select a world hex. So if you click on here, left click, in create root mode, it probably shouldn't do anything unless it's an owned tile, right? Yeah, so let's go ahead and start implementing that. That should be in the building hex, I believe. Unity? There we go. Okay, so when we are in demolition mode, create root mode, we don't know what we're doing yet. Okay, so when we left click on it, right? Yes, when we left click on it in root creation mode, first thing we should do is check to see if it's a player owned hex. So we could just copy this here. So we do something along the lines of that, and then we copy in this as just a bit of a placeholder. And then we will do stuff. Okay. So I think I'm going to go ahead and put a cut in here, and next episode we will start implementing the actual creation, editing, and removal of roots. See you all then.